Vanakkam. Welcome to this video on biomechanics. We have been looking at biomechanical analysis of the joints of the upper limb. Specifically, we have been solving some simple problems in the static equilibrium of elbow joint. So, in this video, we will be looking at biomechanical analysis of elbow joint problem in static equilibrium. Here is a simple problem. A person is holding a ball or some weight, okay, that is 10 kg, and is holding it at some angle such that this angle is 55 degrees. It is not holding it at the forearm parallel to the floor, but rather like this at some angle, an angle of 55 degrees. The mass of the forearm is given to be 2 kilograms, that is acting at a distance of 150 mm from the axis of rotation O along the forearm, okay, along the forearm. Now, the question is determine the reaction force at the elbow joint, the reaction force is here, and the tension in the biceps muscle, okay, so that the moment about O is 0. That means that the whole joint is in static equilibrium. Find the tension T in the muscle. Also, what is given, let me erase my own writing. What is given is that the perpendicular distance between the line of action of force for the muscle and the joint is 50 mm. Okay. This is what is given. Now, as is usual, let us try to analyze this using our back of the envelope approach. Remember that this time I may not be very accurate, and I know that I may not be very accurate. Why do I know this? How do I know this? Because in earlier problems the angles were simpler and rather easy for me to make assumptions in this. This angle is 55 degrees and I do not know, I do not seem to have a very clear intuitive understanding of what this could do. That is okay. I have always told that the idea of this back of the envelope approach is not to give you an accurate answer. The idea is to give you an idea, the idea is to give you some sense of the scale in which the answer is going to be. Is it going to be hundreds of newtons, or is it going to be thousands of newtons, or is it going to be tens of newtons? This is where the idea is. So, let us try this. The muscle is attaching at 50 mm and the perpendicular distance between the load and the joint is 150 mm. Note that this is the distance that matters, okay. The perpendicular distance between the line of action of force and the joint axis of rotation is what matters. So, that is about 150 mm. So, this is 10 kg, let us say this is 100 newtons. So, I am going to have about 300 newtons in the vicinity of that somewhere, but somehow I am not comfortable with that. But I do know that it is going to be in the hundreds of newtons range, that I am somewhat confident about, because because there are 350s in 150. I am not even counting this 2 kg load, I must count for this, right. So, I know that at least the answer is anywhere in the hundreds of Newton range, okay. With that in mind, let us try to proceed with the problem. This is a rough free body diagram of the situation. So, the forearm free body diagram is given, this angle is given to be 55 degrees, okay. This is the joint O, and an unknown muscle tension T is acting here. I do not know the value of this force, but what I do know is that this distance is 50 mm. All the dimensions are in mm. When I am drawing, all the dimensions are in mm. Okay. This is 50 mm. What I also know is at a distance of 150 mm along the forearm, not in the xy axis. This is the xy axis I am going to assume. At a distance of 150 mm along the forearm, at that distance the mass of the forearm is acting, and that is having the weight 9.81, sorry 2 times 9.81. Okay. Now, and 10 times 9.81 weight is acting at a perpendicular distance of 150 mm, whereas here this distance is 150 mm. It is a slight difference. I just realized that this distance cannot be 150 mm, because if the distance along the forearm is 150 mm, for the perpendicular distance to also be for 150 mm, you need to have a different angle. So, I just rechecked, this is not 150 mm, but rather 330 mm. Please note this change. Okay. The perpendicular distance between the external load and the joint of rotation is 330 mm. Okay. So, this distance is 330 mm. Remember this. Okay. Okay. Now, what is asked? What is asked is the unknown tension in the muscle and the joint reactions of the elbow. So, I have to do sigma f x 0, sigma f y 0, sigma m is equal to 0, but I would start as usual with the moment equation, because it is likely that I will have only single equation in single unknown. So, I can solve for the tension T straight away. However, before we proceed, I thought somehow this distance 150 mm is along the distance where the mass of the forearm is acting is along the forearm, but I am interested in finding that distance that is perpendicular to the line of action of force. The line of action of force is acting here like this. The perpendicular distance is that, is it not? That is the perpendicular distance. So, I want to know what is this. This is the moment arm of interest for me. Well, the moment arm is also a vector. I can resolve for this. That is actually then using principles of trigonometry, I could simply write this out as r is equal to 150 times sin 55. Okay. Now, I can write out the equation. Remember, when you are writing out the moment arm, you will have to write it out as 150 times sin 55. You could of course solve this by resolving the force along the bar, but then that is slightly confusing for beginners. So, let us resolve the moment arm along the x axis, okay, because the distance that we know is inclined to both x and y axis, and I am interested in finding the distance along the x axis. Why is that? Because the mass of the forearm is acting along the negative y axis. So, I am interested in finding the perpendicular distance, which is the distance along the x axis. So, I am interested in finding this r, and that r is 150 times sin 55. Now, I can write the moment equation as sigma m equal to 0, counterclockwise considered positive. Okay. That is the equation. I can write this as I start with the tension T. That tension T is a positive moment because it is going to cause a counterclockwise moment. Okay. And it is having the perpendicular distance. In this case, the perpendicular distance itself is given. So, that is actually 50 mm, 50 by 1000 or 0.05. Okay. Minus, because this 2 kg is going to cause a clockwise moment, which is a negative moment, minus 150 sin 55 divided by 1000. Remember this, 150 sin 55 is the perpendicular distance, this distance, that distance. This is 150 sin 55. Okay. That is the distance times the force, is it not? 2 into 9.81. Let us not forget the 9.81. Okay. Minus, because the 10 kg is also going to cause a clockwise moment. So, it is minus 10 into 9.81 into 330 by 1000. In this case, the distance is perpendicular. So, that is fine. Only for the case of the mass of the forearm, the distance is given along the forearm, then you will have to resolve it along the x axis, because this weight is acting along the y axis and you are interested in finding the perpendicular distance. Remember, this perpendicular distance is always dropped. So, this is the perpendicular that is dropped on the line of action of force and the joint axis. Okay. Line of action of force is where the perpendicular acts. Any other force that is there? Answer is no. So, I am writing this as equal to 0. So, after all this analysis, I find the answer as, so this is one equation in single variable. After some algebra, or my request is for you to try and simplify this. You will find the value of T as 695.67 newtons. Essentially, take all the terms that does not have T to the right hand side and then take the 50 by 1000 to the right hand side, then you will essentially get this answer, 695.67. Our back of the envelope calculation gave me an answer in the hundreds of newtons range. I said 300 newtons, but I was also quite uncomfortable with that answer. I said, no, that is not exactly likely to be true, but I am somewhat confident that the answer is going to be in the vicinity of hundreds of newtons, somewhere in the hundreds of newtons range. It is not going to be 1000 of newtons and it is not going to be tens of newtons, it is going to be in the hundreds. So, that way I at least have some, this is not the way to verify this solution, I am aware of that, but many times I see students who write the answer as 69 newtons or 6000 newtons. Somewhere along the way there is a simple numerical mistake, and because you will use this T to find the reaction force, and the reaction force will then be wrong, and I cannot give points for that. This is something that I have picked up by looking at students' answer sheets over the last 10 years of teaching engineering mechanics. So, you need to have an intuitive sense of where your answer is. That is something that no one can give you, that is something that only you can develop yourself, you can learn yourself. So, you need to work on this and build this intuitive understanding of this solution. This is something that is not given to you, no course can teach you this, a lot of practice can teach you this. Okay. Then we are interested in finding these the reaction forces OX and OY. I am interested in finding OX, sigma Fx equal to 0, right side going is considered positive, but there are no forces that are acting along the x axis, all forces are acting along the y axis. So, that means that the reaction force OX is 0, there is no reaction force along the x axis. Then what about OY? That we can find by saying sigma Fy equal to 0. Okay. So, OY is along the positive y axis, T is along the positive y axis, and then you have minus 2 times 9.81 along the negative y axis, minus 10 times 9.81. So, then OY is, take all these terms to the right hand side and use your scientific calculator to simplify this. You will find the value of OY as minus 577.95 newtons. What does this mean? A reaction force is negative in the direction shown. That means that reaction force is actually positive in the opposite direction. That means that it is 577.95 newtons in that direction. It is going down along the negative y axis. Along the negative y axis, the magnitude is 577.95 newtons. Along the positive y axis, the magnitude is minus 577.95 newtons, or this force is acting along the negative y axis. That is what we learn from this. So, with this we come to the end of this video on solving some simple problems in statics of the elbow joint. Thank you very much for your attention.